have a lightning talk on eliminating anti-patterns to build reliable system by Anupam. Yeah, so by Anupam Sin, who is the SRE director of American Express. Put your hands together for Anupam.
Hello, can you hear me? All right. Hi, everyone. Thank you for joining me in here today to hear my talk. So, I'm Anupam Singh. Oh, you have to have a different presentation. Sorry, I was supposed to speak at 2:15, and it's last minute changed, so that's somebody else's presentation. Yes. Done? All right. Yes, this is me. So yeah, I'll be talking about eliminating anti-patterns to build reliable system today. Before that, little bit about me. So I'm working as an site reliability engineering director with American Express for 3 years now. Very thankful to GHCI and Amex for providing me this opportunity and platform. GHCI hold a special place in my life because 3 years back on the same platform, I got an opportunity to work with Amex. So that's why. This is a little bit about Amex, how we are placed worldwide, and we are growing every day from business and technology perspective. Now, without any further delay, I will just jump on to the talk. This is the agenda. It looks like 5 slides, but I'll cover it in 10 minutes. Okay, so talking about reliability, what basically reliability is. If I take the literal meaning, it is basically reliability in software. So the probability of error-free software at any given point of time is reliability. But why there is so much talk about reliability, so much fuss about it, and a lot of buzzwords about reliability and SRE teams. So now think from a perspective of a user or a customer. If you are using a software or an app which crashes frequently, which is very slow and which errors out, would you like to use that app? No, right? As a user, I would never want to use that app. So the answer lies beneath that why it is so much fuss about reliability and why it is so relevant. So my talk will be about, I will give you some tips on how we can build reliable system. I mean, I cannot finish that in 10 minutes for sure. It's been 3 years, we are still building the reliable system. So, I mean, everybody wants to build a reliable system, and it's not just a role and responsibility of one team, as we hear so much about site reliability engineering. It starts from the first phase of software development. When we talk about reliability, there's another thing which comes along with this, anti-patterns. So what anti-patterns is in a software? Now you see this picture, it is like a very smooth and a flowery walk initially, and in the end it's like walk with all monsters. So same is anti-patterns. So anti-patterns are like anything that hinders the performance of the software, if we talk about software language. Now, these are opposite to the best practice, and some of the problems or I would say mistakes unknowingly or knowingly we do while we build our softwares, which impact huge in later end when we actually release software to the live customers. So in my previous 15-ish years of experience, I have curated the content, and whatever I have learned so far, some of the common anti-patterns that I have seen in software development lifecycle. So I have divided into these phases. If I give you a very brief overview of, let's say we start with design. So one of the common mistakes that we do in design is when we start initially from scratch, it's a small software, and eventually it grows. we make one service like a God service, which has multiple dependencies, and which become like a um, bottleneck for software reliability. Second is development. There is now n number of best practice. As you guys are software development, you would know there are n number of best practice in software development and engineering. But one very big common is copy and paste. We know we should not do it, but we still do it. It is okay if you do copy paste, which is fine, but you have to understand that if you are working in a project which has 200 other developers, you have to make sure that your code, even if you're copy pasting, it should work with the code if other 200 developers are also developing along with you. Testing, we know that our testing environment and production environment are never replica of each other. No matter how many times we say that it has to be replica, it is never. So the thing that it is in our control is replicating the production scenarios in our test suite. This is a common mistake that sometimes I have seen people do while they are designing their test cases. Other is change management and release management. These are two of the process-oriented anti-patterns. Though they do not introduce any bug in the software directly, but if they are not prioritized properly and they are not automated, it will slow down the performance of the software and the pace of software development. Another one is operations and SRE. They are very close to my heart because I have been working in SRE and operations for around 7 years. So lack of prioritization in your defects and incidents for operations and metrics. So SRE, we all know that how important the metrics is. Even though you choose metrics and you choose it wrong, you will not be able to measure the performance of your software rightly, and you will not know how your customers are feeling. Last is communication and collaboration, very close to my heart again. It's a process-oriented, ignored most of the times, but it has a very broad impact. Though you have all the process and standards in place, if there is no leader to track those process and standards, your whole process and the software development performance of development also will fail. So these are some of the common anti-patterns. Okay. So how would you identify some of these anti-patterns? There are n number of ways. I can cover only few in this 2 minutes. So, very easy approach. You have to divide and rule. We all know what divide and rule is. So, you have to divide each phase of your software development life cycle into small pieces. And then you have to clearly define the roles and responsibility of each phase. Once you divide that, these are some of the very basic questions then you ask that where are the most failures? What is the most time-consuming task in each team in software development? What are the most repetitive failures you have? And what are the things that teams are complaining about the most? If you list down all these few problems, at least you will know what your problems are. You might not have answers or solution on the spot, but you will know what problems are. So I think this is how you will identify anti-patterns in different phases of software development. Now, I also have solution. In the 10 minutes, I will be able to provide a solution. Okay, so this is again, it's like a threefold approach, I call it. And it has worked for me in American Express and in the other previous organization where I have worked. So whatever experience I had around reliability, I have made it as a threefold approach in a solution, which is one is measure. Measuring is very important. Now, it's not just the measurement at the end of the software when it is live out there. You have to measure in each and every phase starting from the designing phase. Testing phase, software development phase. Even when you have, like in some of you guys, you have business analysts who provide you the requirement, the measuring should start from that phase itself, and it has to be realistic metrics. You can't say your software will always be 100% up and running. You can never meet that. Second is feedback loop. This is something which we have implemented, me and my team have implemented in our team. It had worked like wonders. We missed this feedback loop many times where We have so many teams working. We have a lot of good collaboration and communication. We are breaking all the silos. Yes, this is all good. But feedback loop from what is happening in production environment all the way to, let's say, testing team, development team, to the product team, I think this is where we sometimes miss and there are gaps. So the feedback loop from the team that works directly on production environment, who know what is happening, and then giving that feedback to, let's say, development team and testing team, and development team and testing team, let's say, giving feedback back to SRE. So it's like you are looking a product and developing a product from a perspective of customers. Yeah, there are other user researchers and other designers as well who work directly with customers on how the look and feel, but how actually system is performing. We have to have a good feedback loop, and after implementing this feedback loop, we have increased 30 to 40% of the performance of our software development, and we have bring down our issues as well in production environment in the current project. Last one is culture. We all know that how SRE and DevOps, what was the baseline for SRE and DevOps is blameless approach. We talk a lot about it. We need to have like a leaders who focus to build on this culture of a blameless approach. It goes long way and it helps a lot in building a good software which is out there and user would want to use it. And I think the last one is that we need to have clear goals for each and every team in software development lifecycle phase. So that is what solution from my side. This brings end my presentation. Lightning talk. If you have any questions, you can ask me. Thank you so much. Any questions? You can connect me on LinkedIn. Scan Amex for career. How to build good system.
Thank you so much for that inspiring talk. So I call up Poonam to please give away a token of appreciation from our side, please. So once again, put your hands together for her. Thank you so much. Moving on to the next lightning talk, I call upon Pooja Arora and Mrudula Priya on the topic, the architectural paradigm shift, asynchronous concurrent application with virtual thread. So it's mic. Sorry for the technical glitch. We get it started very soon. I'll do that.
Hello. Hello. Hi, everyone. I'm Radula, and I have Pooja with me. And we'll be presenting on the topic of architectural paradigm shift, building asynchronous concurrent applications with virtual threads. Next. So this is a brief agenda. So we'll talk about different types of threads, and then we have a interesting demo where we will do a deep dive, and the floor will be open for questions. Slide. So starting off with a brief background about threads. So threads were introduced in Java way back in Java 1.0. So as you can see in the diagram, multi-threading in Java was primarily driven by the platform threads, which had a one-on-one mapping with the operating system threads. So this leads to a lot of bottlenecks like memory, as well as limited scalability, given that you have a limited number of threads at your disposal. So next. So how does all these problems, are the current application that we have, right? How they are dealt with in the current concurrency model. So currently, the web servers, our applications make use of web servers as well as microservices that require thousands of threads, which put a lot of strain if we are using traditional threads, right? As well as increased resource consumption, given that if we implement the current models using the traditional threads, it will have a huge strain on the current implementation because the memory usage is going to be huge. And finally, the complex asynchronous programming models, basically, because the non-blocking execution threads are going to be implemented using callbacks or futures, which again is very difficult to maintain for developers, right? So we need an easy solution which the developers can actually maintain and can implement easily, right? Okay, so what's the solution to all these problems? The solution is virtual threads. So virtual threads are lightweight, and as you can see in the diagram itself, right, they are maintained by the JVM, which helps remove the main important bottleneck that there was, which was around the memory usage, right? So, and one other thing that you can see in the diagram, right, is that the mappings, right? So here, the virtual threads are mapped to a fewer number of platform threads, where in the previous traditional threads, there was one-on-one mapping. So this actually gives a very huge advantage to virtual threads and help build the modern applications that use thousands of threads, like microservices. The next slide. Okay, so now that we have an introduction about what traditional and virtual threads are, now we'll do a deep dive into the threads, right? So touching upon the advantages and disadvantages of the traditional threads. So we already talked a little bit about that, right, already. So definitely, traditional threads have good CPU usage, which helps implement actual parallelism. They are mature, they have been in the system, they have been utilized by a number of frameworks, so they are mature. Most of the developers are attuned to it. Thread pooling is another very major advantage, given that it helps utilize the threads that are at your disposal in a very efficient manner. And definitely, they are very easy to use. Now, touching upon the main disadvantages, thread blocking issues, as well as the most important one is the expensive context switching, wherein you have a lot of resources which are wasted because of it. Now, I'll pass it over to Pooja, who will delve deeper into virtual threads. Thank you.
All right. Thank you, everyone. Hi, meeting you. Happy to meet you all. I'm Pooja. Let's talk about virtual threads now. What virtual threads are, why it make it good to use for our application where we talk about running millions of virtual threads concurrently. So they are lightweight, as we already know. Of course, their calls are non-blocking. I'm gonna show you a demo which is going to talk about how we claim it's lightweight, how we claim it's non-blocking, and they are managed at application level. That's where it reduces the context switching time, also the resource utilization. So let's have advantages and disadvantages first. Of course, we already talked, it's a lightweight, that means it must be using lesser memory. You can run millions of virtual threads concurrently, and your application would be amazing if you are running the high I/O extensive operations. Now, what happened in virtual thread actually, as you know, Radula mentioned that traditional threads are mapped with the operating system threads. That's not the case with virtual threads. One virtual thread would mount on a carrier thread, performs the task, and then unmount and free that carrier thread for the next virtual thread. That's how they make the lesser time in context switching, and they uses the less resources. But nothing comes for free. What's the problem? We are doing mounting, unmounting on a carrier thread. That means it can lead to the problem of starvation. It can lead to the problem of starvation as well. How? If your carrier threads are limited, then my virtual thread cannot run that much concurrently, and that will lead the problem of throughput reduction as well. Since slides are moved, I'm going to show you the demo. This demo will extensively talk about how you make it lightweight, how mounting, unmounting is happening, and how you can run millions of concurrent threads parallelly. For this demo purpose, I have created one sample application. This application will have both traditional and virtual thread, and we would see how it's behaving when you increase the load. Let me walk you through a quick demo. All right, so as promised, we have a demo with the sample application. For now, let's use 50 traditional threads, and what we are doing, worker via worker method, it's very lazy, it's just sleeping for 4 seconds, that's it. And in the end, after this sleep of 3 seconds, I am printing thread.executed successfully. That's it. Let's run this code and let's see what it will. We all know the behavior, but let's see it live. Okay, thread executed successfully, no surprise, it was expected. Now, let's play this application. We will increase the thread counts to 500. And these are traditional threads, please note. Let's run. Any guesses what will happen? Okay, so we see few latency, but it executed, so not bad. Let's try to increase now thread count to 10,000 traditional threads. What do you think? Will application die with 10,000 traditional thread load, or it will run? All right, let's find it out. Oh my God. My application literally died with the 10,000 traditional threads. I see out of memory error now. That's how we see the load on the traditional thread. Now let's do one thing. We have claimed a lot that virtual threads are lightweight and virtual thread use a less time in context switching, less resource utilization, so much claim theoretically. Let's see practically. What I'm going to do, just one line change from thread to, I'm going to use thread.start virtual thread. And let's run it for 10,000 virtual threads now, where our application died earlier with the traditional thread case. I think it should run, so let's not guess, let's run it. All right. It executed. No big deal because of so many claims. Let's increase the thread count to now 100,000 virtual threads. Okay, now I'm gonna pause. Any guesses? It's really huge count. I think now my application is going to die again. Let's find it out then. Okay. Okay, I'm still waiting. I see latency. Wow. With 100,000 virtual thread, my application could run, can handle the load this much. Now let's go to the part 2 of demo. In demo part 2, we will see I/O extensive operation, and we would also see how it's releasing the carrier threads. So with the interest of time, let's quickly go there. What this is having, one more thing I want to highlight, we don't create thread like we created earlier. Java gives us the executor service for our real application. So let's use executor service. I'm going to make counter as 10, executor.new thread pool with the thread pool of 100. And what we will do here, we will call the worker in a loop. And in this loop, I am also sending the index count, which is 0 to 10. And what my worker is going to do, notice it's printing index entering thread dot current thread. And then we are doing IO operation as we talked already. And we would print index dot exiting thread dot current thread. Let's run this and find out the application behavior. Okay, so results are not sorted. I'm going to make it sorted according to the index. What we see now, this. Notice indexes are coming in the left side, and at the right, observe thread 1 entering, thread 1 exiting. Observe for index 3, thread 4 entered and thread 4 exited. Also observe for index 8, thread 9 is entering and 9 is exiting. Nice. That's a traditional thread behavior. Of course, these are having blocking calls, so it's not gonna mount like the virtual thread. But we claim that virtual thread does the free carrier thread. So let's do one thing. Let's make a minor change. I'm going to make just one line change effort to change this whole executor service to run the virtual thread. And that's the beauty of executor service framework, just one line change. What I did, executors dot new virtual thread per task executor, that's it. Let's run this application and find the behavior. For the demo purpose, I have kept it sorted for you. So notice index 0, worker 1 is entering, but exiting is 6. Okay. Notice one more example here. Let's talk about index 2. What we are seeing, worker 3 is entering, worker 5 exited. So with that, what we just saw, that is a mounting and unmounting of the virtual thread on the carrier. Whenever the IO operation is coming, it's making a non-blocking call. That's how we are making. So can you please change to slides again? Isn't it amazing? All right, let's go to the $100 million question. Which thread you would like to use when it comes to your application? So by now, all of you have your answers available. If your application is IO extensive, go for the virtual thread. And if you think your application is gonna be computation extensive, then I would recommend go for the traditional thread only. That's pretty much for today. Thank you so much. Anna?
To present a token of appreciation from our side, I call upon Poonam, the session chair, to the speakers, please. So once again, put your hands together for both the speakers for this amazing lightning talk.